चलो जी, ओके। बच्चों मुझे बताएं कि मैं जब इस तरह वेब डायग्राम्स और स्पाइडर डायग्राम से एक्सप्लेन करता हूं तो आई होप इट डज नॉट गेट कंफ्यूजिंग फॉर ऑल ऑफ यू। आई ट्राई टू बी एज नीट एज आई कैन। कुछ थोड़ा इनपुट दे दें प्लीज। क्या ख्याल है बच्चों? ठीक है, ऐसे ठीक
Oh,
है
it's
या
readable. I've
readable?
printed it. It's pretty readable. Yeah.
Oh wow. Are you printing it with colored printouts or black and white?
Black and white, and then like I highlight them.
Wow, that's
Points.
amazing. You run away from writing, huh?
Yeah.
Okay. Chale, at least
Biology,
you're
there's a
honest.
lot of writing though.
Yeah, it is. It is. Stay tuned for more. So just fasten your seatbelts.
Oh.
Challenge. Okay. So, challenge. So, inshallah, let's begin. So, the next topic is a very important, but a very interesting and a very small topic. That's the lock and the key hypothesis. Okay. Lock and key hypothesis. Okay, let me quickly explain what this is. And then with the pictured diagrams, inshallah, I noted diagrams, I will explain all what this process is all about. Acha ji. So, lock and key hypothesis explains enzyme action, which basically means how enzymes they work. Okay, how enzymes work. And in this particular scenario, in our example, the lock is considered the enzyme and the key is the substrate. Okay, the key is the substrate. Another way of explaining all of this is that the way the lock and the key fit, so it's all about the fitting analogy. Okay, sorry, the way the lock and the key they fit into one another in the same way enzyme and substrate fit into one another. Okay, ji. So that's another way of explaining what lock and key hypothesis is all about. So inshallah, now what I'm going to do is I'm going to be drawing diagrams and explaining all what the lock and key hypothesis is all about. So point number one. Chale ji. So let me draw the enzyme. Okay, let's draw this one. So the first thing that happens is, let me use another ink for the substrate. Let's use pink ink. Okay, so that's the substrate. And of course, that's the enzyme. And let me highlight the way I highlighted the active site. All of us know that this is the active site. Okay, so let me label this as the active site. Acha ji. So the first point into our explanation for lock and key hypothesis will be that the substrate approaches the enzyme. Let me write that down here for you. The substrate when the substrate approaches the enzyme and is ready to fit into active site of the enzyme. Acha, thoda sa we need to understand, bachon, what do I mean when I say this? approaches. ये क्या मतलब घूम फिर रहा होता है इधर उधर. देखें, you have to understand, when we are talking about a chemical reaction taking place, that is taking place in an aqueous solution. Listen to me carefully, let me repeat. When we are talking about a chemical reaction taking place, jahan pe enzyme is working, it's always happening in solution form, right? In water, in aqueous form. So we know that the molecules, they have this energy that causes them to move, and therefore maybe the substrate is getting closer to the enzyme. Can anybody tell me what's the name of that energy that causes the molecules to move in the first place? We've talked about this earlier also. Ji bachcho.
So ATP.
No, not ATP.
Sorry, your voice is breaking up again and again.
Oh, really? Turn it on. Okay, is it better now? Bacho, is my voice better or is it still breaking?
It's clear for me. I can
It's
hear you.
better.
Okay, Chalaji. So my question is, why are I said that the substrate is approaching? I mean, why is it approaching in the first place? Because it has that inherent kinetic energy that is causing it to move in the first place in the situation, in the solution. Okay. बच्चों जरा एक दफा मुझे सब बता दें. Is my voice clear? Because मेरे side पे तो signals पूरे हैं. It's maybe somebody. Can everybody give me a
वो
yes in the
clear आ
mic?
रही है.
ओके, मुझे किसने कहा था, मुझे जिसने भी कहा था, आप एक दफा जरा अपना कनेक्शन भी थोड़ा सा देख लें. Just connect and disconnect and then connect again. Maybe that will help, inshallah. Okay, challenge. So that's step number one. Step number two, what happens is that, and that step number two is very important actually. The substrate, it actually enters the active site. So let me redraw that, and let me use the same color that I used. So the substrate literally enters the active site like this, okay? And you call this entire thing as the enzyme. Let me write that down with a different color. You call this thing as the enzyme substrate complex. Call that thing as the enzyme substrate complex. Now, of course, in terms of points, there's some few important things that we need to know. So the first thing is that the substrate enters the active site, enters the active site, which is complementary. Now, this is very important, which is complementary in shape. और ये बहुत important point है, इसको मैं अभी highlight करने लगा हूँ. This is complementary in shape. Okay. So a substrate which enters the active site, which is complementary in shape, and forms enzyme substrate complex. Now, again, this word is very important. If you are talking about the lock-in key hypothesis and you're not mentioning the word enzyme substrate complex, then guess what? You're not credit worthy for marks. Okay, so please ensure that you do mention this. Our complementary in shape ka matlab hai, of course, they can fit into one another. The active site has complement. Yes, okay. So that's where basically the main reaction takes place. The reaction takes place. Of course, the bonds are being broken. Bonds ki kya detail hai and all of that stuff. You don't need to go into that details. So that's the second point of this. The third, once the reaction is complete, then what happens is the enzyme will, of course, remain the same. But now what is formed is known as products. So the products are formed, and then, so let me write them down. So these are the products that have been formed, okay? These are the products, and they are being released from the active site. Again, let me highlight the active site for you. So that's the active site. So in terms of points, of course, we are going to write The chemical reaction is completed. Products are formed, and they're not only formed, they are also released from the active site. This is a very important point. Again, khali bache likh dete hain, products are formed, but they don't write this, that they are released from the active site. So again, that's important because it's very important for the products to be formed to get released from the active site. Why is that the case? Because then, point number 4, the enzyme is now ready to be reused again. Well, enzyme is ready to be reused. Is now ready to be reused. Okay. So that's all what lock and key hypothesis is supposed to be all about, including all of its explanation. ठीक है, मैंने उसको annotated diagram के साथ जितना simple हो सकता था आपके लिए कर दिया. Of course, all of the points that I've highlighted, you have to ensure that you mention them also. Okay. So this is basically the lock and the key hypothesis. ठीक है बच्चों, अभी good so far?
Yes.
चलिए
Yes,
जी,
sir.
अब आगे चलते हैं. और अब जो अगला टॉपिक है, गेस व्हाट, वो एंजाइम्स का लास्ट टॉपिक है, लेकिन इस पे हम थोड़ा सा टाइम गुजारेंगे इंशाल्लाह. दैट इज द इफेक्ट ऑफ टेम्परेचर on the enzyme activity. Again, it's a very important topic and you will find papers filled up with this topic. So effect of temperature on the activity of enzyme action. Okay. Now, again, there is some understanding that is required here, a pre-understanding, if you like, as a context. Dekhiye, you understand that whenever we are talking about activity of enzymes, we are talking about aqueous solution. And when I say aqueous, of course, that means chemical reaction is happening in solution form. And if it is happening in solution form, then we understand that the molecules, they also possess this kinetic energy, which is causing them to move in the first place. Okay. Acha ji. So I am going to show you a graph, okay, first, और फिर इंशाल्लाह मैं आपको points देता हूँ, which you need to understand. And of course, we also need to talk about what denaturation and all of that stuff is supposed to be about. The graph is very important in this particular scenario. Okay, there you go. Okay, इस पे जो अभी text लिखा हुआ है, just ignore the text that has been written. Inshallah, I will explain all of that in a while, but I just want you to look at the graph, okay? Now, on the x-axis, you have the temperature. Okay, that's of course degrees Celsius. You need to mention the name, sorry, the units. And then you have rate of enzyme activity. Okay, that's the rate of reaction, if you like. So let me write that down here as a slash, rate of reaction. Okay. Acha ji. Now, if you look at the graph, initially, as you are increasing the temperature, you can clearly see that there is an increase in the rate of reaction. Okay. And then initially वो थोड़ा है और फिर then it goes really steep. As you keep on increasing the temperature, the rate of reaction increases. But this happens up till a certain point in the graph, which is the following. And that point is known as the optimum temperature. So if you remember, The optimum temperature is the temperature at which the enzyme works the best. And the rate of reaction, as you can see, is the maximum. Okay. And then something happens. Inshallah, I will just explain what that something is. The rate of reaction starts to decrease, even if you're increasing the temperature. And then at this particular temperature, you can see that the rate of reaction is becoming zero. So we need to understand what is happening, which is causing all of this to happen. Okay. So uh, let me explain. Let me label this graph as different points. So let me choose a color that will stand out. Orange. Okay. So let me label this as point A. So at point A, what is happening is that, generally, point A को लिखने से पहले, let me write this down as a general rule that when temperature increases, the reaction becomes faster. Remember this just as a fact. Okay, now we are going to go into explanation. So at point A, what is happening? The reactants and the enzymes are making effective collisions. Now, what exactly is an effective collision? Let me explain. Okay, if that's the enzyme and that's the substrate, if this enzyme hits at this side, it will just hit the enzyme and move away. If this side hits this area, it will just bump off. But if the collision happens here, we will call it as an effective collision. The reason why we will call it as an effective collision is because this will result in the formation of the enzyme substrate complex. Okay, so that's what I mean that when I say reactants and enzymes are making effective collisions. Okay, what that means is that enzyme substrate complexes are being formed. Complexes are being formed. Okay. Acha. Then point B, which goes something like this. Point B पे क्या हो रहा है? As you are increasing the temperature, what increases? The kinetic energy of the molecules, it also increases. So I hope my using abbreviations is comfortable for you to understand later. So the arrow का मतलब increase है. So increase in temperature causes increase in kinetic energy. Therefore, more effective collisions. Okay. And of course, therefore, more enzyme substrate complexes. Again, I'm just writing the abbreviations. और अगर ज़्यादा enzyme substrate complexes हैं, then the rate of reaction also increases. Okay. Do you understand this line of argument, बच्चों? ये बहुत important है. देखें, this is really important. Increase in temperature will result in increase in kinetic energy, and that results in increase in effective collisions. That results in increased enzyme substrate complexes, and that eventually results in increased rate of reaction. Is everybody clear on this point? Bachcho, come on, give me a yes, please. This is really important. Okay, great.
Yes, sir.
अच्छा जी, लेकिन ऐसा होता नहीं जाता. आप टेम्परेचर इंक्रीज करते जाएं और वो होता जाएगा. No, it's at a limit. Look at, so let me label this as point C. At point C, well, okay, let's look at what the diagram has to say. let's look at this particular table. It says at low temperatures, fewer successful collisions. There many successful nahi kaha, many effective kaha. It's one and the same thing. Enzymes plus substrates have less kinetic energy, low activity, so less substrate turned into product. Okay, that's exactly what I mentioned. And then look at point B, what they've mentioned. Increasing temperature, more successful collisions, more substrate turned into products. Okay, but I've made it easier for you in terms of points. Now, point C, it's the temperature at which the activity is maximum. ठीक है, और इस टेम्परेचर को हम क्या कहते हैं? This is known as the optimum temperature. ठीक है. Now, what happens at optimum temperature? The rate of reaction is maximum. Okay, what that means is that their kinetic energy is also maximum. Okay, sorry, increase नहीं, इसको मैं brackets में लिख देता हूँ. That their kinetic energy is maximum. And therefore maximum enzyme substrate complexes are being formed, and therefore maximum rate of reaction. That's the line of argument basically. Let me write that down here for you, which means okay, maximum enzyme substrate complexes. Okay, then if you look at the picture again, at point D, the graph has started to come down. So what is happening at point D? We need to understand that due to high temperature, which is slightly above the optimum temperature, the enzyme starts to denature. And I'm going to use a different ink to write this down. Starts to denature. Okay, now we need to understand what denaturation means. So let me write that as a subheading. Denaturation is basically change or distortion in the active site, in the shape of the active site. So for example, let me draw the enzyme that I drew earlier. So for example, if that was the enzyme, okay, after denaturation, it would become like the following. तो अगर पहले इसकी active site की shape इस तरह की थी, now the shape of the active site is going to be something like the following. So you can clearly see that the shape of the active site has actually changed. Okay, so this is basically shape changed. ठीक है, इस process को हम basically क्या कहते हैं? Denaturation. The consequences of this are substrate is no longer complementary. Substrate no longer complementary. और अगर substrate complementary नहीं है, then of course no enzyme substrate complex and no reaction taking place. Anyhow, point D पे मैंने आपको कहा है कि it starts to denature. Again, I want to highlight this. Start of denaturation का क्या मतलब है कि the reaction will not stop instantaneously. It will take time. Therefore, you can see that the graph at D has started to move down. It has not instantly gone down to zero. Okay. So due to high temperature, the enzyme starts to denature. Or denaturation शुरू हो रही है, तो what that means is that fewer enzyme substrate complexes, therefore less rate of reaction. Okay. All right. And then at point A, B, C, D, E, that's a point which marks complete denaturation. Denaturation of enzyme. What that means is that the active site has been completely distorted. Active site completely distorted. अच्छा जी, और यहाँ पे अक्सर बच्चे एक सेंटेंस लिख देते हैं जो कि मैं लिख के उसको गलत करूंगा. एंजाइम इज किल्ड. नो, इट इज नॉट किल्ड. You don't use this word. It is completely denatured. Enzyme, Anika, is not a living thing. So we don't have to use this word. I'm not saying that you use this word, but I hope you understand what I mean, okay? So the enzyme is completely denatured. Okay, so this is basically what the effect of temperature would be. Effect of pH वाला topic भी है, इसके कुछ paper questions भी हैं. इंशाल्लाह वो मैं आपको आज मैंने सोचा था कि इस topic को हम wind up कर लेंगे. The pH is actually also quite similar. It's not that different. Let me quickly give you a graph of pH also. Let's see how much thing. I don't want to jump the gun. मैं काम करता हूँ. Quickly, let me make PDF notes of these. So what I'm doing is that मैं आज इस topic में आगे नहीं चल रहा. Okay, so what? Nothing is sent for printing. Why? Print. Okay, let me see कि इसका format ठीक आ रहा है. Yep, the format is perfect. Alhamdulillah. Okay. But any questions that we have for today? मैंने आज टॉपिक क्योंकि ये छोटा सा ही था, अभी पूरा खत्म नहीं किया. I still want to talk about something more about this topic, but still, generally speaking, I hope nobody had some major issues with the enzymes. Make sure that all of the keywords and all of the stuff that I've used, आप उसको जरा अच्छे तरीके से देखें. Make sure that when you come tomorrow in the lesson, you have revised all of the stuff that we have done today, because it's only then it is going to be an effective activity of doing the past papers. I plan to spend the entire lesson tomorrow doing past papers for this particular topic, that's enzymes. Okay, so please make sure कि आप past papers देखें. आज क्या date होगी बच्चों? It's 14th today. Yep, it is 14th of December. Okay, 2020. बच्चों, no questions for today? Yes या no तो बोल दें, क्या हो गया?
No, sir.
Okay, चलें, alhamdulillah. So wait, I'm not asking you to leave. I just want to see that this. Okay, so inshallah हम enzymes का topic कल खत्म करके on Wednesday I will be beginning with the topic of plant nutrition. इससे syllabus में अगला जो sequence में है वो plant nutrition है. और plant nutrition के साथ usually I do combine plant transport also, although after plant nutrition in the syllabus you have animal nutrition, but inshallah once I start off with plants I will continue with plants and I will be giving you plant क्या कहते हैं, I want to take a picture, I want to send the file. Plant transport, I will do those topics combined inshallah. और usually plants में ही बच्चों को अक्सर काफ़ी ज़्यादा मसला होता है, so inshallah we will get rid of that topic first and then proceed. ठीक है, चलें जी. So if you don't have any questions, then I'm calling the class as an end for today. और ये मैंने आपके साथ आज की क्लास नोट्स भी बच्चों शेयर कर दिए हैं. Please make sure that you take a note of them, inshallah, and keep them safe. आप अपना बहुत ख्याल रखें. आपसे कल मुलाकात होगी again the same time, 8 p.m. Thank you, jazakumullah khairan, and assalamu alaikum wa rahmatullahi wa barakatuh.